Hello, let's solve the problem number 114, a flattened binary tree to linked list. Okay, given a binary tree, flatten it to a linked list in place. For example, given the following tree, 1 to 5, 3, 4, 6, the flattened tree should look like the following. It's almost like a linked list, but tree data structure is still used, which means that all nodes are linked using the right child pointer variable. You can see the tree node data structure here to solve this problem. Okay, let's think about what the idea is. Okay, I drew the original tree data structure. We have to find a way of manipulating this tree structure to the flattened shape. It would be done in recursive way to implement as a simple algorithm. When we use the recursive function, its behavior would be performed from the bottom to the top level node. I'm going to describe the manipulation in detail. Let's start with the left child node. We go down the tree node up to the number 3, and we could know that the number 3 is a leaf node, so we go back to number 2. At this point, we are going to modify the left child node, which is number 3, move it to the right child. So the number 2 have the number 3 as the right child, and the number 3 has the number 4 as also the right child, and we go back to number 1. And we do this one more time, so the number 1 has number 2 as its right child, and number 5 is connected to number 4 as its right child. With these two operations, we can have the flattened tree. This is the simple behavior we can do using recursive function because it's performed from the leaf node towards the top node. Okay, let's see the solution. I implemented a flat function doing this behavior recursively. You could see that this function is called for the left child recursively. As I explained just before, this function goes down following left child node up to the bottom, which is number 3, and then it will return itself because it has no children. Get_RC function is actually trying to return rightmost child node. Because as you can see in the picture, number 4 should be connected to number 5 as its right child. This is done when the number 2 moves to right child of number 1 at the flat function in top level. So at this time, the flat function should know the rightmost child, number 4, to connect it with number 5. In the code, LC pointer stores the return value of the flat function, which would be the result of a get_RC function. Get_RC do the behavior of finding the rightmost child at the bottom of the tree. This part is the most important, which is the manipulation of moving left child to the right child by updating its pointers. Right child pointer is first stored in temp variable, and move the left child to the right child. And then in this code, the previous right child is stored in LC right pointer. This is the behavior of connecting number 4 with number 5. And the tree's left pointer is initialized with null pointer. Because flattened tree has no left child, this behavior is performed recursively in upward direction. After that, we could get the flattened tree. Okay, this code performs 8 milliseconds, which is faster than 66.42%. Thank you for watching. See you next time. Bye bye.